All right, now I'm going to show you how to weld a circular part. So a couple things I want to cover first. I want to keep this robot with this joint here, J6, I want to keep that as vertical as possible. A couple reasons. Number one is that gives me a nice 45-degree work angle to maintain as I go around. Also, it minimizes the amount of movement in all my joints. If I leave it nice and vertical, I'm going to basically spin around just J6. So this is going to be doing the majority of the movement. If for some reason I have a steep torch angle like this, to get around this part, what's going to happen is you're going to see a lot of movement in these joints, and you may end up with something like a elbow speed error that exceeds the collaboration speed that's set up in there for safety. Also, the robot may have difficulty keeping the speed at the wire where it needs to be because the robot is having to make a lot of coarse adjustments to keep that speed at the tip of the torch at the right speed. So you want to keep that up and down as much as possible, as long as you have the clearance between your part and this right here. If you don't have enough clearance, you may be stuck with a little bit steeper angle and you may not have a choice. But if you can, I would keep it there. Also, this allows us to use our custom manual guided teaching function, which I'll get to in a second. So I want to try and maintain that and keep that straight up and down when I'm doing a circle. Also, when I'm doing a circle with a robot, each axis is limited to 270 degrees of total movement. So if I start here and I'm at the 0, I'm only going to go 3/4 of the way around this circle before I max out the joint, and then I'm going to get an error and it's not going to go all the way around the circle. So what we do to get around that is we're going to preload the torch halfway under the arm. So it'll be negative 180 degrees. And then we'll go out to 0 and then wind up to 180 degrees, or vice versa, whichever way you need to do it. So first thing I'm going to do is I'm going to minimize my 3D view of my robot there because I don't need that. And I'm going to prepare my part then to actually do the weld. So what I do is I mark every 90 degrees. So I have a mark at 3, 6, 9, and 12 o'clock. The best way to do that is kind of stare down from the top of your part and just put in some points. If I try to just go at this guessing where those points are and eyeing them up without some kind of visual cue, I'm likely not going to have 90 degrees between my points, and then I'm going to get errors that say stuff like circle angle too large, circle angle too small. So we want to try and keep those equidistant. So you need 2 circular moves to get around a circle. Each one is an arc, half a circle, and they're called weld point C in here. So with a circular move, you have whatever the previous point was, whether that was a weld start, a linear move, whatever that move was. It takes that point, and then we go from that point, whatever that last point was that we made, we'll go 90 degrees and we'll put in a circular move. When you put in a circular move, it puts in 2 points. It only records the first one. Then we'll go another 90 degrees, so we're 180 degrees from where we started, and we're going to touch up the second point of that weld point C that it put in there. So it takes all 3 of those points and does the math, and it plans out the path to get around that circle. Then we would do another 90 degrees, so now we're 270 degrees from where we started. We put in another weld point C, and then we go 360 degrees from where we started, and we touch up the second point of that weld point C. So you'll need a minimum of 2. Now, depending on how big the part is, a part this size, I would use 4 circular moves. The reason is because depending on how well the tool center point was set up on your torch and just the part fit up, you can get drift between those parts. If I have a circle that's this big and I got a point over here and a point here, it's planning that path all the way between those. And that's a long path to plan without any issues without drift. So the more points that we put in there, the more it forces the torch to stay down to hit those points, and you'll have less drift and you'll keep it right, you'll keep the wire right in the joint. So I went ahead and I marked all these and I labeled them. So when we're doing a circle, we're going to start out with our weld starts. We'll come in, we'll approach right before our weld start, then we'll come down, we'll hit, and we'll do a weld start. So if you have newer software, it's going to be something like a weld start with motion. If you have older software, it's going to be basic arc. Either way, you're going to put that in at that point. Then you're going to go 90 degrees from there. This is where you're going to put in a weld point C. So with the newer software that has weld start with motion, you're just going to put that weld point C after it. If you have a basic arc icon, which is U-shaped, you're going to drag that weld point C inside the U-shaped icon. And you're going to see 2 points again. It'll show 2 points, but it only recorded the first one. Now we're going to move another 90 degrees, which is 180 degrees from where we started. We're going to highlight the circular move, and we're going to touch up the second point. Then we're going to move another 90 degrees, so now we're 270 degrees from where we started. And I'm going to put in another weld point C. And then finally I'm going to move another 90 degrees, and now we're back to where we started, 360 degrees from the beginning. And I'm going to touch up the second point of my weld point C. So now this is where things kind of diverge a little bit. If you have the newer software, you're going to have something called a weld end standalone. So a weld end standalone is just an instruction that tells it, okay, turn the arc off. There's no point associated with it. So that's the point where I would put in my weld end standalone. If you're using basic arc, you need to go into your basic arc function now, and you need to highlight that icon and then touch up the weld end. So with the old basic arc function, you now have 2 points at the same place. You have the last point of that last circle move, and you have your weld end. The only problem that poses is if you ever go to touch up those points, you've got to remember to touch up both of those points at the same place, because if you don't, if you only touch up one and forget to touch up the other, what's going to happen is it's going to move to the old position. With the newer software, I have the advantage of just putting a weld end standalone in there. So it's not a point, it's just an instruction that says when you get to that point, now turn off the arc. So I'm going to put this into position, and I'm going to have my weld start pointed towards the robot. So the weld start will be my 6 o'clock position. I've already went ahead and created a program called Circle. So I have my robot operation tab up. I'm in the free manual guided teaching mode. And before I do that, I want to record this point for my home point. So I'm going to put a J point in there. Now I'm going to pull the dead man, and I'm going to force it to come out here and put a point in. And then I'm going to record that. If I didn't do that, if I just went right from here to down here, I'm likely going to hit the part. So I'm forcing it into this path. Now I can keep moving, and now at this point, this is where I'm going to get the arm with J6 nice and straight, and I want to start getting into position here. So now this is nice and vertical. I got my 45 on my torch. If I want to put a little push on there, I can do that. So now I can move that a little bit. And then I'm going to record that as a J move. Now I'm going to go to my custom manual guided teaching. You'll notice that X, Y, and Z are highlighted, enabled on the right there. That is basically my translation. And then I have rotation around Z enabled. If I didn't use this, this is a nice feature. If I didn't have this, I'd have to go between translation and rotation constantly. I'd have to go to translation to move it in space. I'd have to go to rotation to spin it around, and then back to rotation or translation, to get into the joint. When I'm in rotation, this can lean this way, it can spin around all these axes. I don't want that. I want this to stay nice and straight. So by turning off rotation around X and Y, I'm only rotating around the Z axis. So now I can move in space, my X, Y, Z, and I can rotate at the same time. It's a great feature. I love this. So now I want to move into my approach point. So on my teaching weight, I'm going to go around 30%. I don't want to get it too loose so that it'll act just like in translation, where if I have it too loose, it's going to get away from me, and I don't want that. So I want to keep it kind of tight. So now I'm going to move into an approach point right above the weld start. And let's record a J move there, and then we're going to go into the weld start. And now I'm going to go to my menu on the left here to Arc Tool, and I'm going to drag a Weld Start with Motion into my timeline. We'll go back to robot operation. Now I'm going to move from the 6 o'clock position to the 3 o'clock position. It does take a little bit more time to do the rotation with this because I do have the teaching weight kind of tight, simply because I don't want it to get away from me when I'm moving in the translation mode in my XYZ here. So now I have it at my first point, so I'm going to drag a weld point C into there. So it recorded it as point 6 and 7. It recorded 6, now we're going to touch up 7. So we need to move over here to the 12 o'clock position. So just be patient. It's a uniform pressure. You don't want to force it. It's resisting for a reason. It's giving you more control. So you just have to be more patient. Don't force it. Okay, so now we're 180 degrees from where we started, and this is my second point of my first weld point C. So I'm going to highlight point 6 and 7 there. I'm going to minimize my robot operation tab, and I'm going to touch up point 7 there. And you'll see position 6, position 7. The second point is the one further down, so you're going to hit the bottom touch up button. Now I can deselect that and then go back to programming. So I'm going to go back to my robot operation tab. I'm going to move around here to 9 o'clock position. There we are. Join. Okay, now I'm going to drop in another weld point C. So it recorded points 8 and 9. So it actually only recorded the position for 8, not 9. So we'll record 9 now. So now we're going to move over here to point 9, which is back to the start, 360 degrees from where we started. There. Okay, so now I'm going to minimize my robot operation tab. I'm going to highlight point 8 and 9, and I'm going to touch up position 9 and hit OK. So again, my two circular moves here, if I was using basic arc, those would be inside of that U-shaped icon. So now I'm going to drag a weld end standalone into there. So now it's telling it an instruction but no point attached to it. And then I'm going to go back down to my robot operation tab. I'm going to do a retract point somewhere up here in space away from the weld end. I'm going to go to my history so I can just use a J move there again. And now I want to go to free. And I want to put a point here before I go back to 1. I can't just put in a J move and change it to 1 and have it go back to 1 because it's going to take the shortest path. So if I'm here and point 1 is over here and it's closer to go this direction, what you're going to see is it's going to try to go this way and it's going to limit out. And we don't want that to happen. So we need to force it to go this direction. So what we're going to do is we'll put one intermediate point here that also ensures that we're not going to hit our part. And then we can put in another J move to go back to home. So I'm going to move this up here so we ensure that we're clearing the part. I'm going to drag a J move in there, and then I'm going to drag another J move in there. And now point 12 I'm going to highlight, and I'm going to change point 12 to point 1. So now we'll go back home. And then the last thing we need to do is we need to set up our weld schedules in our icons. So I'm going to go to point 5. I don't have to have a wire feed speed or voltage in there. All I need is a travel speed for the robot if I want to dry run. Because what will happen is it's going to get down to that weld start 0.5 and it's going to give you an error because it doesn't know how fast to move the robot. So if I'm just doing a dry run, all I need is robot travel speed. But if I need to weld, then I need to put in all the other parameters. But I'm just going to go in here real quick, and I'm actually going to speed this up for the sake of time. I'm going to go into my schedule list, and this is all covered in another video, by the way. I'm not going to go into detail here. I'm just going to bump my travel speed up to, let's do 60 inches per minute so it goes quickly through there. Okay, so now I'm going to choose my weld procedure for rapid arc, weld schedule 1, and then for my weld end, I'm going to use the weld procedure for rapid arc, weld schedule 2. So now we're all set up. All I need to do now is disable my tablet, go to my play tab, put it in 100%, and when I hit the green button, it's going to go back home to 1, and then it's going to start at the beginning of the program and walk it through. Now you'll notice that those air moves were very robotic, for lack of a better term, but they're fine moves. The J moves and the L moves, when you put them in, they default to fine termination. Fine termination, if you remember, is going to go right to the exact point in space. If we change it to continuous will cut the corner off. So you'll notice, again, what it's doing there is it's going right to that point, stopping, then moving, stopping. That can cause a couple of issues. It's going to add cycle time. It's also going to wear the arm out sooner, though these don't move as fast as industrial arms. An industrial arm moving like that would wear out the brakes extremely quickly because you're stopping, full stop, and then taking off and stopping. It's like running your car full accelerator when you leave the traffic light and then slamming on the brakes at the next traffic light. You don't want to do that. That's not good for your car. And it's not good for a robot either. The other thing is, you may get payload errors because it's stopping abruptly and it's feeling the inertia of the mass moving still, and it may throw a payload error. So what we can do is we'll enable our tablet here, and I'm going to go to each one of these J moves, and I'm just going to highlight it, and then I'm going to change the route to continuous. So continuous, remember, will cut off the corner. It will it gets very close to the proximity of the point in space that you program, and then it keeps moving on. It's great for air moves when you're not welding. If you're welding, you're generally going to use fine termination, except if it's a weld point in the middle, you want that to be continuous. You don't want it to stop in the middle of a weld because you'll get a clog. You want it to run continuously through there. So fine moves are for very specific situations. We're going to change all these to continuous, and now I'm going to go back to play, and I'm going to run this again, and you'll see how much more fluid it moves. There was no stopping. It was a nice fluid movement through all those air points. There you go. That's how you write a program for a circular part. If you have any questions, feel free to give us a call or check out our library of videos online for how to do other programming tips.